Welcome to this model number 5. Again, we are going to discuss about other materials and material selection. This chapter, electro rheostat and magneto rheostat materials and quantum tunneling composite we are going to discuss. So let us start with the first one, that is electro rheostat and magneto rheostat material. So here, this electro rheostat, simply we call as ER material, are fluids which can experience that dramatic change in their viscosity. Okay, so when this exposed to an electric field, the air fluids can be simple as a milk chocolate combination. Okay, or cornstarch or and oil. So and also it developed for this use in clutches and valves as well as engine mounts designed to reduce the noise and vibration in vehicles. So in other hand, the magnetostat material are fluids which experience a velocity, a viscosity changes that when exposed to the magnetic field. The most of the common form of MR fluids consist of a tiny iron particles suspended in oil. Okay, so we can see this figure. So this is a fluid where it is going to be. We can see observe this electrorheostat or magnetostat materials. Okay, these MR fluids are being to be developed for use in car shocks, damping, washing machine vibration, and prosthetic limbs, and even for the exercise equipments also they are used, and other surface polishing of machining parts also can be used. And in this both types of material, the effect of change in viscosity can be completely reversed in just a quickly when it is respective dielectric or magnetic field is going to be removed. Okay, so let us discuss about one more concept, that is a quantum tunneling material. So what is quantum tunneling material? So generally we call it as a QTC. Is a composite material. It is having a highly elastic and non-conducting polymer containing that tiny metal particles in it. So it is also a normally called as insulator, because as there is a thermal resistance is high, so we can call it as a thermal insulator, or it is simply called as insulator. But when it is combined or squeezed, it changes it as a conductor. That is one of the very different property here. So this QTC can be used to make membrane switches like those used on mobile phones, and pressure sensors and speed controllers. These are all different types of um, properties which are having the quantum tunneling composites. So this is the material we can see here now for this Q2C. Okay, and further we are going to discuss about one more application is this one, that is a color change materials and shape memory alloys. Also we can discuss in this video, that is color change materials. The color change materials means the materials that are changing the color in response to change in temperature are we called as thermochromic material. Some thermoplastics and liquid crystals are capable of displaying different colors at different temperatures. So these liquid crystals find application in a thermometer for room, refrigerator, aquarium and medical use, and this indicates the level of propane in the tanks. So on the other hand, what we can see, the materials that are change color according to different lighting conditions are called as photochromic material. Such as materials are used to security marker that can only be seen in the ultraviolet light. Okay, these are all about the color change material. Even they are used for the refrigerator or some other sensitive devices. Based on the light detector, it will be changing the color, so it is easy for identifying the material. And next one is shape memory alloys. What is mean by shape memory alloys? This is shape memory alloys, simply we call as SMAs, are a unique class of metal alloys which exhibits two very unique properties like a shape memory alloy effect based on this changing temperature and pseudo elastic nature, and based on this the internal stress also is going to be find out. So there are two effects as we discussed. One is the shape memory effect, another one is pseudo elasticity or super elasticity. So first, what is meant by shape memory effect? So when this shape memory arises in it is cold state, the metal can be bent or stretched and will be held at these shapes until heated above the transition temperature of the body of the alloy. Okay, so upon heating this metal, going to changes its original shape. So when the metal is going to be cooled, it will be remains original shape. So until it going to deform again. So in other words, what we can say, the alloy appears to have a memory returning its original shape, and this is called what shape memory effect. And for the super elasticity or pseudo elasticity, the shape of the alloy memory alloys exhibits super elasticity, that is a mechanical type of shape memory. In case of this force induced considerable deformation in the alloy material, but when it is force is removed, the material is automatically recovers its original shape without need for heating. So pseudo elasticity effect is observed when the alloys are stained just above the transition temperature. So among the various shape of memory alloys like copper, zinc, or aluminum, copper, or copper, nickel, aluminum, or copper, bolt, aluminum, or iron, manganese combination, even for the copper, cadmium, or aluminum, cadmium, and even for the nickel, titanium alloy. These are all referred to as nitinol. Okay, and it is widely used for the commercial applications. Okay, so here we can see this structure for the shape memory alloy. So understand how the structure is going to be changing. This figure shows for one of the example, lithanol is an example. So here we are seeing that 2D view of lithanol crystalline structure. So this is it's a low temperature martensite form, and it can be easily deformed a new shape. Okay. So however, when this alloy is going to be heated above its transition temperature, it is changes back to its austenite form and it recovers original shape. So in this high temperature austenite phase, the alloy is going to be, remember the shape and it has before it was deformed. So this inherent phase transformation of methanol due to change in temperature exhibits the shape memory effects. So in this pseudo elasticity, or what we call super elasticity, wherein the alloy is going to be transferred between the martensite and austenite phase in the response to the mechanical stress. So in this figure you can see observe that the nithanol alloy is loaded in austenite phase. The material will going to be transferred to the martensite phase, and above this critical stress, the proportional to the transformation temperature, we can observe here. So this upon this continual loading, the stress free twinned martensite will going to begin to retwin. So allowing to this material undergoes a large deformation. So once the stress is going to be released, the martensite transfer back to its austenite. So and the material is recovers its original shape. So this is an inherent phase of transformation of the ethanol due to change in stress exhibits the super elastic effects. So these are all about the shape memory alloy. So then for this we'll have some discussion about the applications. So in automotive industry they are going for for automotive thermostats. Okay, and even for the medical used in fixed orthodontic treatment for wide dental movements. For aircraft it is used for vibration dampers to dissipate energy and dampen vibrations for the launch vehicles. Even for the other fields like for robot actuators to mimic the smooth movement of the human muscles, or even for the solar actuators and electrical circuits and fiber optic couplings and mobile phone antennas, and even for the satellite antenna also they are going to use. And finally it is used for these what we call column foundation bolted joints and slender structure for control of buckling of vibrations, etc. So this is about all about the shape memory alloy. So other topics will be discussed in the next video.